Yeah, hello everyone. My name is Lukas Lutz. I'm responsible here at GFT for the global business development in the industry sector. And it's really a big pleasure for me to be here today in the virtual booth of Google and share my view on how we can bring artificial intelligence and digital twins, especially, to life in real industrial production environments. And let me say a few words, or let me start with who we are as GFT. We are founded over 30 years ago here in the Black Forest in Germany, and we grew to a global corporation, actually listed in the Frankfurt Stock Exchange, um, but really still carrying this family owned company spirit in our hearts. We consider ourselves as technology experts specialized on building software solutions for our clients in the finance industry and the largest insurers of this world and the biggest manufacturing companies in industry. And that's especially an industry where we work very closely together with GCP and just got announced the Breakthrough Partner of the Year in 2019, which really made the whole team very proud. And data and software is really at the core of everything we do. Our roughly 6,000 software engineers are located in more than 16 locations around the globe to serve our customers really right where they need us. And we see ourselves as the bridge between the hardware world on the one side and the software world on the other, where we build the digital solutions, combining our strong industry domain expertise from more than 1,000 industry projects actually, with deep software technology and competence on the other side. But let me say only so much to who we are, and we only have 15 minutes, I think. So let's really jump right into the topic and see how we can leverage these new fascinating software technologies like AI, like cloud, like digital twins in real production environments. So let's start with AI. I mean, we all know that AI is a big buzzword and everybody uses it to paint glossy slides like this one here, for example. But unfortunately, that's often related to very little tangible business value in the real world. And today I would like to shine some light on how GFT and GCP work together to bring AI to life in the industrial context and really create immediate monetary benefits to our customers. So let me start with a general comment on AI. I'm by far no AI or deep machine learning expert, but to know where AI really has its benefits, the message is you don't really need to be. I wouldn't also consider myself an event manager just because I use Google Calendar to organize my day, right? And that's exactly the point. AI is a very powerful technology to really structure, manage, and optimize our complex world in a new way, more efficient. And imagine you would still be using paper calendars or only communicate by a letter, right? It's almost impossible to manage a global operation successfully, especially in these times where we're living right now. And if I would have only one goal today, then it's to demystify this big mysterious terms, AI and digital twins a little bit and show you how we work as GFT very closely together with Google to make these technologies available to a broader audience and democratize the benefit we can have from them in your business. Because one thing is clear, the ones who don't adapt AI in their business will be the ones communicating by letter pretty soon. So let me dive right into it. I'll show you a couple of examples of what we are working on together with Google to really bring AI into the industrial environment and add immediate value. And I'm talking about a matter of weeks until our customer sees benefit. Right? This is really true. You can do a POC within a couple of weeks and immediately see the concrete benefits the AI brings to your business. My first example is about automating very tedious and highly labor-intensive processes, like, for example, reading through thousands of pages of documents of specifications. In Germany, we say Lastenhefte, right? We use our vast experience we have here from the financial sector, where we're used to large amounts of documents and process, for example, legal documents and lawsuit documents, and extract the relevant information and provide a digital automated report to the user in the end. And that usually consumes very highly paid employees and withholds them from really actually doing their actual job. And by doing so, by using this computer vision combined with AI technology, we can really gain efficiency. We can boost efficiency up to almost 90% and thereby achieve ROIs of under 1 year. And that really demonstrates how quickly we can implement AI to really demonstrate the actual value we bring to the client. The next example have been developed by our data scientists and really on the shop floors of the largest manufacturers around the world. It's all about using visual inspection based on computer vision and Google's AI technology to leverage really the benefits of this technology here. Here we really use the power of GCP machine learning algorithms in the Google Cloud to analyze images taken on the shop floor and identify objects, in this case packages, or determine almost at real time the quality of machining processes. In this example, we can see an example where we provide instant feedback on the quality of welding process, for example, taking very little, taking all the very little tiny features into account. And the goal is always to automate the image ingestion here for metallic welding parts and process these with high speed to really provide instant feedback of the quality and directly to the quality manager. In this case, AI is the best employee because it has the best eyes, looks extremely closely, detects even the smallest analogies, and calculates faster than anyone else. And this really makes the life of our workers, and here in this case really the quality manager, much easier. And to go one step beyond and fully understand why the quality is like it is, we really need to enrich that image information with various other data sources like ambient sensors, for example, or data coming from machine processes itself. That simply helps the AI to better analyze and determine if the product's quality is within the standards and actually where also the potential root cause for this error is. And again, AI can monitor so many parameters simultaneously and look so closely that quality is really raised to a new level. And that's what we really see when implementing these examples at our clients. And I picked these examples for a reason, because I wanted to show you how fast and easy it is to implement one solution where you have just analyzing some images and creating already a lot of value. Then in a second step to also include other sensor data and machine data to find out root causes and really go into the processes of the enterprise. And this information really gives you a broader picture of the real world situation. And that's where the true value of AI lies, because AI likes the complexity. And we are no doubt moving really towards highly automated production environments. And I'm sure that in 15 years, the majority of the production lines will be highly efficient due to the use of software and AI. But to go there, isolated use case and applications of AI are not enough. It's really about integrating your data sources and generate a holistic representation of what's really actually happening in the physical world and in the digital space. I want to jump into the next buzzword I'm sure you all know, which is called digital twins. And this is often interpreted as simple dashboards, right? But and you can see that here on the left side of the slide. But a dashboard does simply only display certain manufacturing data, like machine data, like RPM, downtimes, or utilization figures. This gives surely the worker or the line manager information about the productivity, efficiency, and health of the machine, and is a great tool to improve operations with real-time information. But for me, the concept of digital twin goes far beyond that, far beyond dashboards. In my eyes, the concept of digital twins should not be looked at as a representation of an individual machine parameter, because in a factory, there is also never any isolated machine standing somewhere doing something without affecting any other environment around it, right? It's all about being connected and being integrated. And at GFT, we look at the industrial companies as really one connected stream of data from the development department over material procurement and production down to the sales process and the customer interaction. And the value of data really grows up exponentially if it covers the entire process. And imagine you could get feedback from if you're a car manufacturer, for example, if you could get feedback from car telemetry on certain parts and include that knowledge directly in the development process and saving costs by avoiding, for example, any design failures that cost you a lot of money when you have to have recall actions later on to get these cars sorted out of the market again. And that's why we believe in integrated software solutions that are highly adaptable and scalable, but always fulfill the need of the people on the ground, and not some techies that simply love software. But coming back to the digital twin topic, digital twins are an extremely powerful tool to separate the physical world from the virtual world, and by building really a virtual representation of the physical world with all the information, all the semantics, and all the connections that are there. And let me explain why this is so important. Think of digital twins like if you were dreaming. Imagine you could be able to control your dreams. You could simply have a second life without limits and without boundaries, right? You could try out what happens, for example, when you ramp up the production in one location and when you decrease it in another, for example. Simply look in the future what happens. And actually that's not even so new. I mean, Formula One is doing that basically before every race and even doing the race, right? To test and improve their performance during and for the next race. And I mean, digital twins, not dreaming. And to do so, to enable this technology, we really need a proper, realistic digital representation of our physical environment to really simulate different scenarios and look into what is going to happen in the future. But to do so, we need a little bit more than a simple dashboard. And at GFT, we have been working on this technological challenge for the last 10 years. With the learnings of more than really 1,000 installations, we built a digital twin framework that allows you to create and connect virtual systems where all relevant physical objects are represented as intelligent digital objects, knowing about their functionalities, their features, their physical parameters, and their history. And what is really important, and not a matter of course, the objects are really directly networked with all business systems and processes. Similar to a human being, you also know what you are, you know what your skills are, I mean, most of the time at least, you know what your looks are, and to whom you communicate. And that's exactly what we need here too. So step one for us is always the vertical connectivity, where we integrate the data sources coming from the physical world, so sensors, machine, devices, into a digital space. Step two is then to enriching that data with the relevant semantics, so the corresponding information about the data source itself. So what kind of machine it is, what kind of product it produces, and also certain technical information, could be, for example, CAD drawings. In the next step, then, we need to embed these intelligent data objects into the process environment, which is ongoing in your IT environment of your company. You have MES systems, you have ERP systems, you have PLM systems that are all part of this virtual representation, and we need to include that as well. Like in the real world, nothing is really existing in a vacuum, but it's all linked to each other and the processes and systems around it. And that's even more so true for data streams. So if we now combine this new world of digital twins with if we have that virtual representation and we combine that with the enormous compute power we have now available in Google Cloud, we can really enable this AI dreaming process where we can calculate extremely complex scenarios to see what is going to happen in the future. And if we would like to take certain actions right now before something is happening. And imagine how much time, how much money, how much nerves and material you would be able to save, and how much better you would sleep at night if you could perfectly simulate far-reaching decisions even before you start. So if you could really realistically dream the future. And GCP is absolutely leading in the field of artificial intelligence. That's why we are so super happy to have such a strong partner at our side to really implement such projects. What we as GFT contribute to this partnership are three dimensions. First of all, our decades of industry experience. Second, a very sophisticated framework based on a digital process twin. The architecture, what we call actually model in the middle, is an integrated part of our digital twin platform, Sphinx Open Online. And this really coordinates the data mapping, the connection, the evaluation, the monitoring, and the forecasting in one central model. and acts as a bidirectional connect between this virtual world and the real physical world of things. And in that way, we can not only receive data up in the virtual space, but we can also execute any kind of optimizations and commands derived from that data back in the real physical production environment. And third, we contribute a proven combination of rules and artificial intelligence. And this is the last very important message I want to give you today. AI needs rules. You can't just use output from an AI to act in the physical world. That's way too dangerous. There needs to be a layer in between that mimics how the human would actually act. And this is what we implemented in our digital twin platform to really drive fully autonomous systems. So after that very technical deep dive, let me finish with a concrete application of such a system. Imagine you would have a production that consumes a lot of energy in heating or cooling processes, for example. And you would waste hundreds of thousands of euros per year on energy peak loads that occur from time to time. Imagine then you would have our system in place that would tell you in advance that such an expensive energy peak load is just about to happen before it does. And this would really enable you to act and prevent such energy peaks from happening. But of course, you wouldn't just shut down in the real world. You wouldn't just shut down the entire production line, or rather, or kill a switch on the heating oven. But you would rather dim some lights, maybe decrease the air conditioning a little bit, or lower the charging current for electric vehicles outside. And to really enable a fully autonomous system that does that regulation by itself, we need to mimic the same behavior as a human would have. So in other words, you need the optimization potential of the AI, but you also need the action guidelines that apply in the physical world. And that's why we integrated a terminate rules engine in our system. And this is what actually the crucial step towards a fully autonomous closed loop system that uses AI, optimizes stuff, and acts in the real world, which is now available for your factory. Because at GFT, we believe that the future will be highly efficient for those who apply AI and digital twins in their facilities. And we are very happy to have a partner with Google on our side to make companies more competitive for an AI-driven automation in the future. Thank you very much.